Okay, in this video we're going to look at solving real-life problems, and this is an example that is similar to what we did in the introduction videos. If you need some more examples or another example of that, please refer to that video, to the first, it's actually the second video in the introduction to this section. So just like there, we had 4 test grades and one of them was missing. We wanted to find out what the missing grade would have to be in order to achieve a particular average. Well, this is similar. Here we have someone who is riding their bicycle 5 days, Monday, Tuesday, Wednesday, Thursday, Friday, and they have ridden 3.5 miles on Monday, 5.5 miles on Tuesday. They didn't ride on Wednesday, 5 miles again on Thursday, and today, Friday, they want to know how many miles they need to ride in order to maintain their average of 5 miles per day. So let's think about what we have just as we did in the introductory lesson in the introductory video. So our average should be 5 miles a day. On the first day, we are below average by 1.5. On the second day, we're over the average by 0.5. On the third day, we didn't ride at all, so we're down 5.0. On that day, on the fourth day, we're right at the average, so we're neither over nor under. Now, the question we want to ask ourselves first of all is, on this last day, Friday, should the miles that we ride be less than 5, equal to 5, or more than 5? And I think it's clear to see that if you just rode 5 miles on Friday, you haven't made up for the deficits that you encountered on Monday and Wednesday, even though you were over a little bit on Tuesday. So we feel that we should have to ride more than 5, and perhaps a lot more than 5, to bring our average up. So let's see what happens. Can we make a guess as to what Friday should be? Well, the two red values are negative 6.5 and the green value is positive 0.5. Adding them together is going to give us a combined deficit of negative 6.0, which means on Friday we not only need to ride our 5 miles, we need to make up 6 of those deficit miles. So we think that our average, the miles we ride on Friday, should be 11. Now let's set this up algebraically the way we showed in the introductory to the lesson, in the introduction to the lesson, and see if we can confirm that value. So we have 3.5 on the first day, 5.5 on the second day, 0 on the third day, 5 on the fourth day, and x. What we don't know, how much we need to ride on the 5th day. Now remember that you're not going to divide by 4, even though you have 4 actual values. The x represents another day, another value, and so we want to divide by 5, and our average number of miles should come out to be 5. All right. Again, we can simplify what we have, and using your calculator you should be able to get that 3.5 plus 5.5 plus 0 plus 5 is equal to 14, plus x over 5 needs to equal 5. We're then going to multiply both sides by 5. When we do, those 5's cancel. We end up with 14 plus x is equal to 25, and subtracting 14 gives us x needs to equal 11, or the rider needs to bike 11 miles on Friday to keep the average at 5 miles per day. So this is how we can use an algebraic equation to find that missing value there. We'll go on to another example. In example number 5, your school's drama club charges $4 per person for admission to a play. The club borrowed $400 to pay for costumes and props. After paying back the loan, the club has a profit of $100. How many people attended the play? So, in this type of problem, as we mentioned before in the introduction to the lesson, you have a variable amount. Usually, you can find that variable amount by the phrase per person, per day, per mile, per ounce, etc. And in this case, we see that it is $4 per person for admission to the play. So we're going to begin with, we know that we're going to collect $4 for every person. If there are 10 people, we got $40. If there are 100 people, we have $400. If there are 1,000 people, we'll bring in $4,000. Now, from the money that we bring in, we have to repay the loan that we borrowed to buy the costumes and the props. And that loan was for $400. So if we sold 200 tickets, then we would get 4 times 200, or 800. Then we would subtract the 400. But we know that when we end up, we had $100 profit in the end. So that's going to define exactly how many tickets were sold. And so this type of problem, you have a variable amount. You have a constant plus or minus a constant amount, and you have a total value. It's a very typical common type of word problem, or problem that we can use the strategies we've been talking about to solve. So I'm going to start by adding 400 on both sides, and I have 4x is equal to 500 divide by 4 divide by 4x is equal to 125. That's not $125. X is the number of people who need to attend the play, so we say 125 people attended the play in order to end with a profit of $100. And so that'll do it for the lesson, the videos comprising the lesson. The next set of videos will go on to address the homework problem.